Hello everyone, and I welcome you to our second seminar on SPSS, Statistical Data Analysis. And I'm Dr. Clement Zinda, one of the program leaders at the School of Doctoral Studies, Department of Business. And we will be having a second presentation today on measurements and descriptive statistics, which is very easy. This is one of the basic analyses that you generally have to run when you are analyzing your statistical data. Yeah, so I would just like in the other presentations request that you make use of the question and answer section of the presentation to send us your questions, and we will answer your questions after the presentation. The video and the presentation has been recorded, so the recording will be played, and after the recording, we will do questions and answers. Okay, I see we already have a good number of participants who are here. We will be starting in a few minutes from now. I would like to welcome all of our participants, and I really wish you enjoy the time that you spend with us here. And I also hope that you'll be able to learn something from this presentation today. So as you watch, feel free to send us your questions using the questions and answer section, and I will make time to answer your questions. Okay, thank you very much, and see you immediately after the presentation. Hello, everyone. I am Dr. Clement Nzinda, program leader in the Department of Business at UNICAP federal level. And yeah, I will like to present to us today on SPSS, and we will be focusing on descriptive statistics. Okay, I think I made another video which is very helpful when it comes to entering data into SPSS. Okay, so today we are going to proceed with descriptive statistics, which is very easy. It's not very long and very useful as well. Okay, here in SPSS, I have a data set that is already open. Remember during the last video, we learned how to enter data into SPSS. So we have our different variables here that have already been entered into SPSS. Age and the rest of all the variables can be seen there. This is the variable view. This is the data view. Well, this data set was not entered into SPSS by me. Okay, SPSS actually has sample data sets that students and anyone can use just for practice or teaching or learning purposes. Okay, so before I proceed, I think I'll just like to share how to access that data set in SPSS. Okay, for you, so that you can be able to use it to practice and learn how to use SPSS more. And SPSS is very easy to use, very easy to use. You just need to know what you're doing. Okay, and once you know that you can with practice, you obviously become very good at using this particular application software. So to access this sample data, this sample data set, you just click on File, click on Open, okay, and click on Data. Now I already opened it, that's why it's taking me directly to this data set. These are the different data sets that we have integrated in SPSS version 26. That's lots of them. Okay, so you can just pick one and use. But let me just go back, so I can show you guys how to get there. So once you've clicked on open and you want to click on data, okay, you can scroll down, you look for your disk C, okay, the disk C. And when you're in this C, you need to go to the program files. Okay. So I click there, go to the program files and look for IBM. Okay. So once you click on IBM, it's going to take you to SPSS. Double click on SPSS, it takes you to statistics. Double click on that, 26, because I'm using SPSS version 26. So the number that will appear here will depend on the version of SPSS that you are using. Okay, so I double click on that and I have all these that comes out, and then I click on samples. When I click on samples, I have the samples in different languages. Okay, I click English and I have different data sets here. Okay, whatever data set you choose to use, you just click on it and press open and click on open. Now I am using the bank loan dataset for this presentation. It's already open, okay? But if it were not open, I will click on it and then open and I'll be good to go. Okay, so that's it for finding data sets that are already in SPSS. It can be useful for you for practicing purposes, so you'll not be afraid of twisting the data around. You use it to learn. Okay, so we are today going to discuss about descriptive statistics and how to run descriptive statistics in SPSS. Okay, it's very, very easy, very quick. Once your data is already entered in SPSS, entering data in SPSS is actually, for me, the most cumbersome part of the work, but once the data is in SPSS. So for me to get the descriptive statistics of any variable which I have, okay, I just come, click here. So this data set is on bank loan, okay? So I want to get an idea of the descriptive statistics as far as education of the bank of borrowers from the bank and those who already have gotten loans from the bank. I want to see their level of education. So I just click there, descriptive statistics, okay? And then it comes on here very clearly to me. Okay, so you can see here, this is the mean, okay? It's true that it's a categorical variable, so this mean is not going to be very meaningful. Okay, this one is not going to be very meaningful because it's a categorical variable. Remember, we spoke of categorical variables last time. Okay, we saw ordinal variables and we saw nominal variables, which are categorical in nature, and the other type of variable which we have is scaled variable, which is not categorical. Okay, so since it's categorical variable, we don't pay much attention to that. It's not very informative. We come here, so you see the valid entries. This is the number of valid. These are the valid entries. Okay. Now we have 460 entries for persons who did not complete high school. Okay, so this bank has lent out money to, has given out money, given loans to 460 persons who did not complete high school. For those who have completed high school, we have 235, we have 110 for those who have some level of college education. I mean, but they maybe did not complete a degree. Those who have a college degree or undergraduate, we have 47, 49, excuse me, and 5 for those who have postgraduate degrees. So from this, it's very clear that the demographics it's the educational level of those who get loans from the bank tells us that those who did not go to high school tend to take more loans from the bank. Okay, so if I were, for example, in the marketing department in a bank and I see these, okay, it will start telling me, okay, maybe there is some relationship between the level of education and loans, okay, and getting loans from the bank. So it starts to make sense to me, and that might push me to carry out some further investigation. Okay, it might be that those who have low level of education do not have high income. Their income might be very, very low compared to those who have higher level of education. And so due to that, those who have low level of education, lower level of education tend to depend very much on loan to be able to meet up with their household needs. Okay, yeah. So that's it. You can do a quick descriptive analysis for the level of education. And during this video, we'll also compare the level of education and the income. Okay, that might also provide us some additional information. Okay, so let me just close that for now. Okay, now that's one way of doing it. So you just right click on the variable. Let's go to the income of those who have taken loans from the bank, and you just click on descriptive and you can do it. Another way of going about doing the descriptive analysis is clicking on analyze, going to descriptive statistics, and then clicking on descriptives. Okay, now let's just say we want to see the household income, the level of income of those who actually took loans from the bank. So you see the description of this variable, the variable income, household income in thousands. Okay, let's just say thousands of dollars. Okay, and we have that there. Okay, there are some options here, but generally the selected options here are usually good enough. Okay, you have to get a minimum income. Okay, you get a maximum income, you get the standard deviation. Okay, which is the average distance from the mean income or the average income. Okay, and we'll also get our average income. So we click here. Okay, so that's okay. Once we click okay, okay, we can see how the income is distributed. We see the minimum income is 30,000. The maximum income is 446,000. Okay, 66,000. Okay, we see here the mean. Okay, the average income is 46,000. So the average income of those who are taking loans from that bank is 46,000. We also see standard deviation from the mean value. So on an average, other entries, excuse me, the income of different, the income of the different incomes, okay, on an average are 38.5 thousand maybe dollars away from the average value. Okay, so you have your standard deviation here. This skewness and this kurtosis is interesting. Okay, this skewness, these two helps to inform us whether or not our data is skewed. Our data is normally distributed. So generally, you would want your statistic here to be between 3, okay, to be between 3 and -3. Okay, so we see here that the data is not very well, it's not normally distributed. Okay, but that, I mean, that would make sense for inferential statistics. But for now, we just focus on this, so you can have the average income of those who have taken loans from the bank, the standard deviation, and you also see the minimum income, 13 and 446,000 for those who have gotten loans from the bank. Remember at the start, we said, okay, it might be possible that those who are taking loans from the bank, people who do not complete high school are taking more loans, maybe because they depend on those loans to meet, because their income are quite low. I mean, their income is quite low. Okay, so let's try to check that. Okay, so there's another option in descriptive statistics that I find very meaningful. Okay, let's go descriptive. You come to explore. Now this one can actually make some more sense. I already did it. Let me just put the variables back. Okay, so let's say we want to see the household income, okay, and we want to see how that relates to the level of education. So people with lower levels, household with lower levels of education, do they have less money? Okay, they might have less money, and maybe that's what's pushing them to take more loans. Okay, so that's a maybe. But this is one of the weaknesses of quantitative research. It's just the numbers, and the numbers will never tell you the full story. Okay, that's why it's always good to complement it with some qualitative research. Okay, you meet with this particular, I mean, you meet with, in this case, you meet with those who have taken loans from the bank, and you discuss with them what's pushing them, what's motivating them to take loans. or maybe the documents that they fill, they provide an idea of what's motivating them to take their loan. So you can go take those their loan applications and go through them and see what's pushing them to take loans, and then you can have a clearer picture of what's pushing them to take loans. For the moment, let's just say their income is not good. Okay, these guys don't have good income, and we want to use this explore option to check it. I think our statistics, everything here is okay. Plus, yes, we might want a histogram. Yeah, let's just take a histogram. Let's leave this one out for now. It's not very informative. I want a histogram there. Okay, so we have this, and we click OK. Let's see what we have. Okay, so let's go to our descriptive statistics. Now, this is what it's telling us. This is household income. All of this is for household income. So the household income for those who did not complete high school, the average household income for them is 40,000. That's about 40,000, 40,000, about 40,000, 40.8. Okay, so around 40, close to $50,000 per year. Those who have high school, you see it's higher, 6,000. Okay. Those who have some level of college, those who have been to college, but maybe did not complete the program, so some level of college education, 63. Okay. And those who have college degree, 59. Okay. Now, those who have postgraduate degree, 160. So we might already start suspecting that, okay, these guys who did not go, who did not have any who did not complete high school, okay, then to take loans because their income is low. Okay, that's just something I'm suspecting. But I mean, we need to run other more complex inferential statistics to be able to confirm some of these declarations that I'm making. But already from these descriptive statistics, we can see that okay, there is something going on. Okay, that maybe we need us to carry out some more in-depth analysis, or maybe carry out some other carry out more research to be able to gain more clarity on what we are suspecting. Okay, so that's it basically for running descriptive statistics. It's very easy. Okay, so let's just check another one again. Let's still go to analyze, explore. Let's descriptive statistics, we explore. Okay, now let's say we are interested in the debt to income ratio. Okay, so we want to see how the debt to income ratio plays around. So the debt to income ratio here in this particular data set is in percentage. Okay, so that's it. So we have this as a case summary. So for those who did not complete high school, we see, okay, their loans are around 10% of their income. Okay, oh, so maybe they are very watchful about how much money they have as loans so that they should not default on their loans. Okay, then for those who have high school education, is the average debt to income ratio. Okay, it's 9%. So about their debt represents about 9% of their income. Okay, for those who have some level of college degree, it's 10.6%. Oh, that's higher. Okay, maybe they have more income and they're ready to take more loans. Those who have college degree, it's still somewhere around 10%. Okay, and those postgraduates do not want to take loans. Maybe they have very good pay and they see no need to take loans. Okay, so they can carry out their projects well without taking loans. Okay, so if I were still in the marketing department of a bank, I might be interested in this particular demographics. Might maybe be interested here to push these people to take more loans. Okay, if they or have already taken loans, if I see, okay, there is somebody who has college education, for example, and who's, let's just say, what's the minimum value? Okay, and I see that, okay, his debt is just maybe like 1% of his, like 1 or 2% of his income. Okay, then I'll try to push it to see how we can take some more money. Okay, we can take some more loans and of course give the bank some more money as he pays back with the interest. Okay, so basically that's how you do descriptive statistics. Okay, before we close this. And did I put the plots? Okay, yes. Okay, so we can have our histograms. Okay, debt to credit ratio for those who did not complete uh, high school. Okay, you see that it's a little skewed. Okay, it's not normally distributed. Okay, you can see this one also slightly skewed. Okay, so you get the histogram, and that's some other charts there that you might also find useful. So basically, descriptive statistics is very easy. Okay, it's very easy. It's the starting point, okay, of your analysis. After you've done your descriptive statistics, you want to follow up with some inferential statistics to test the hypothesis, okay, that you indicated at the start of your thesis. Okay, yeah, that is it. Maybe just one last thing, since we have some time. There is another thing which we might find interesting in SPSS. Okay, let's say in the case of this bank, I see maybe as somebody working in the marketing department in this bank, I see that, okay, most of the clients who take loans from this bank have not completed high school. Okay, and I want to maybe do some more analysis on this particular demographic group, this particular group of persons, because they represent the biggest group of customers who actually take loans. And I said, okay, let me exclude all other levels of education and deal only with those who have not completed high school. Okay, so to do so, I come to data, click up there, data, select cases. Okay, then we choose the if option. Okay, once you click, and then click on if, okay, we will work with if level of education, we put it there, equals the level of education is equal to 1. Remember, the level of education is maybe before getting here, let me just go to the variable view, okay, and show us. Remember, level of education is a categorical variable, okay, you can see some ordinary variable. So we have entered different values for different levels. Okay, so like did not attempt, did not complete high school has been coded here as 1, and the rest you can see how they've been coded. So let's say we are interested only in those who did not complete high school, because in this case, maybe they represent the largest number of persons who actually got loans from the banks, and the bank might be interested in knowing more about these people, or more statistical analysis on the data they've gotten for this particular segment. Yeah, and then so let's say we just want to work only with those guys. Okay, so we come here to data, click on select cases. Okay, choose if, take the if. Okay, we are interested in the level of education. Level of education, we put it there, equal to 1. Okay, meaning we are selecting those who have been coded in for the variable level of education, those who have received the code 1. Okay, so we're interested only in those cases that have the code 1, meaning that's the case of those who did not complete high school. Okay, so we do that. Okay, click here. Okay, close this one. Okay, now when we come to the data view, you see that there is another variable that has been created, which is the filter variable. The filter variable gives a 0 for all the cases that have been cancelled. Okay, so you can see here for those 2, 3, this is those who have higher levels of education. Okay, so it's been cancelled, and there's the 0 here. Okay, and it shows 1 for the cases that you'll be working with henceforth. Okay, so yeah, that is how you actually do to select cases, and whatever type of analysis you'll be running now would be focusing only on the cases of those who did not complete high school. Okay, now once you finish that, if you want to get back to your data set as it was from the start, okay, then you just come, you click on reset, okay, and you click OK. And once you do that, okay, everything should come back to normal. You can just decide to clear the filter variable, and your data set is back to the way it was before. Okay, so that's it about descriptive statistics. It's very easy to do, and you can also make use of some of these few tips that I shared with you to be able to bring out some meaning for your work. But remember, after you've done your descriptive statistics, you would want to follow up with some inferential statistics to test the hypothesis that you have in your work. Okay, thank you very much for listening, and I hope you find this video helpful. Thank you. Bye-bye.
Hello, everybody. I hope you enjoyed the presentation. Another very good one from Dr. Clement. We're now going to move to the Q&A. So if anybody has any further questions, could you please post them in the Q&A section? So then, will this recording be made available to participants? Yes, it's going to be edited and it will be put up on its own section in the VLE on the Student Help Center within about a month. So, question for you, Dr. Clement. First of all, thank you for the presentation. Very much enjoyed. Does it matter which variable you select first in exploring descriptive analysis?
Thank you very much for the question. Well, it depends on your work and what you are trying to do, but generally for those who are carrying out their doctoral analysis of the data collected for their thesis, the descriptive statistics is generally useful for the demographics part of your questionnaire. Okay, so you obviously need to do descriptive statistics for all of the variables that are found in the demographics part of your questionnaire. Okay, let me just share my screen. Okay, I have my SPSS open here. Generally, when you are doing your research, you collect data on age. Okay, you collect data on maybe level of education. You collect data on, well, maybe number of years. In this case, is the years spent with the current employer. Okay, so all of the demographic data that you collect in your questionnaire, you obviously have to do some descriptive statistics and present them. Okay, and then for the data that is non-demographic, okay, you can also wish to do some descriptive statistics and just show, okay, just for the sake of showing, but then you need to run some form of inferential statistics to test your hypothesis. Now, I would also like to share this because we see some students formulating hypotheses or research questions that are purely descriptive. Okay, and to know that your research question is purely descriptive, if your research question has just one variable, okay, for example, you might be interested to see the level of indebtedness of maybe employees in a particular company. Now, the only variable in such maybe a research question, what is the level of indebtedness of employees of the company X, is The only variable there is their level of indebtedness. So you will be able to do how do I call it, a descriptive analysis, excuse me. You'll be able to do a descriptive analysis for their level of indebtedness. So when you do the analysis, just like if I take like the level, the years of experience, let me just say, okay, something like this. Once you do that descriptive statistics, what you get will be things like this that would not be very, very meaningful. Okay, you'll be able to get the average. Okay, you'll be able to get the standard deviation, get the mean and the mode, which is really, really low level analysis for this particular level. So generally, we'll be making use of descriptive statistics for the demographic variables, okay, in your work. But after that, since your hypothesis should have an independent and a dependent variable, you would have to run some form of inferential statistical analysis to be able to test your hypothesis. Okay, I hope that answers the question.
Excellent. We've got a few questions asking about the video and if it will be later available. Yes, the video will be later available. It will be on the VLE. You'll be able to access it there. Just go to the VLE, go to the relevant link, and you'll find it there. We'll also probably send out an email once it's up telling you where it is, but you can always find it on the VLE. The audio by itself is not going to be available, only the video as a whole. So, could you please explain the filter variable once more, Dr. Clement?
Okay, thank you very much. It's a very, very interesting tool. Okay, the filter variable, you use this option if you want to actually focus on maybe a particular category. Okay, remember last time during the first presentation, I shared with us categorical variables, which could be ordinal or nominal. Okay, and I also explained very lengthily what scaled or ratio variables are. Okay, so generally you'll be using a filter if you are interested in a particular category. Okay, so let's take like the variable level of education. It's an ordinal variable, meaning it's a categorical variable. Okay, and as a categorical variable, we have two of them here. One, it's in XPSS. Okay, you'll see that for all of the variables that have been labeled as categorical, okay, you'll see that values are defined, okay, for each of the categories. Okay, so let's take the category. Let's take the categorical variable education, level of education. Here is ED. Okay. Now we see the different categories here. Did not complete high school degree, some college education, and then we have college degree, those who have actually completed a college degree, and we have here postgraduate. So these are the different categories, okay? So I just wanted to show us that. Now, let's say we are now interested in a particular category of variables, okay? In a particular category, okay? And we say we want to work only because let's just say, okay, in this case, those who did not finish high school have are the biggest number of clients that we have in the bank. Okay. So if you see, if we do the descriptive statistics there, you will see this is the mean. What's most interesting here in this part is the mode, since this is a categorical variable. The mode here tells you the biggest, the entry with the highest frequency, meaning the entry that has the highest number of persons of entries, which is one, the variable one, the category one, and the category one is for those who did not have a college degree. So you see, 460 persons, okay, 460 customers in the bank did not complete high school, okay? So if you look at the percentages as well, you will see that that is 54%. So that's more than 50% of the clients in the bank did not complete high school, okay? So let's say, okay, since this particular demographic is, since this is the largest customer group, okay, or the largest segment of customers that that the bank has, okay, we want to focus on that particular segment as far as education is concerned. Okay, so we say, okay, in our analysis, we want to focus only on the cases of those who did not go to those who did not complete high school. And let's just say that particular group of participants is of interest to us. So what you do is you click on data, come to select cases, okay? Select cases, you add the if condition, okay? When you click on select cases, you add the if condition, okay? And then you click on the if. Once you click on the if, you come here, level of education. Click on the level of education, click on this arrow. It's going to transfer it to this display that looks like the display of your calculator, okay? And so you have actually you have different options here, okay? You can actually use these options. I would encourage you to test them. Like if you use this one greater than or equal to 1, okay, it's going to, or maybe greater than or equal to 2. You take categories that are above 2 and above, and the rest you can take greater than 2 and the rest. So I'll encourage you to play around with them. But let's say we are interested only in those whose level of education, those who did not complete high school, which in this case are coded as 1. Okay, so when I click that and I click on continue, okay, you will see it appear here. Level of education, ED, has been selected. We want to select just those cases, and we'll use any case if the level of education for that particular case is 1. Okay, so once you click on OK, you see that you have canceled out all. If you see, let's just, where's the variable education? Let's switch the view. Okay, now if you see this, the variable level of education, you see 3 has been canceled. This participant actually is coded 3 here. This participant coded 2. Also, all of those who have any level of education which is not which is not coded as 1 will be cancelled. Their cases will be cancelled. And if you come right to this end and look at the filter variable, okay, this filter variable, you see that for every entry that is cancelled, the filter variable enters the value 1. Okay, the filter variable enters the value 1. Okay, now let's just say, for example, now I want to, once I've done that, I want to run maybe a correlation analysis between the income level and let's just say the how do I call it, debt to income ratio. Okay, so then I can run an analysis now, and it would actually just run the analysis only for the cases where we do not that have not been cancelled. So let's say I want to run a correlation analysis. This is going to be presented to you in another presentation. So I correlate. I take by variate, excuse me. Let's just say, okay, I'm interested in their household income and also their debt to income ratio. Okay, so once I do that, let me just run the analysis very simply. Okay, it runs, and this is my person correlation. Okay, table. Okay, so it tells us household income. Okay, and this is the significance level, so that there is a statistically insignificant relationship between the two. And my coefficient of regression of my coefficient of correlation here is 0.015, which means just about there is just about 1.5% correlation between the level of household income and the actual debt to income ratio. Okay, so I can run this correlate only for this particular group, and so everything I'm doing here is only for that particular group. Okay, so once you do that, okay, you can actually use only these cases, that particular case. So Now, if I want to clear it, I can actually just come and clear this filter variable here, which was shown in the presentation. Okay, I can still come to the data, click on select cases, and then I click on reset. Okay, it will cancel the if condition that was put there, and there you go, back to my data the way it was. Okay. Well, the filter variable is still here. I can just choose to clear it. Okay, clear the variable, and everything is fine. Okay, I hope that answers the question. Yeah, hello, Sebastian.
Hello, Clement. What is the
Yeah.
difference between inferential and descriptive statistics?
Okay, thank you. Thank you very much. I think that is a very, very relevant question. Okay. Now, descriptive statistics, as we have explained it, shows you the general tendencies of a particular variable. Okay, so let me just do the descriptive statistics for the level of income. Okay. Okay, well, let me just take the central tendencies here for the level of income. You see the average level of income is this. You see the median. Okay, so if we're to arrange them in a straight line, and then, I mean, in a chronological order, yeah, I think it is chronological, starting from the least, going right up to the biggest, okay, and then we're to choose the middle value. This will be the middle value. We have the standard deviation. Okay, we also have the range, and then we have the minimum value, and we have the maximum value. Okay, so yeah, now the descriptive statistics, this this description that we have here is only for this data set, applies only for this data set. Now, when we say inferential statistics, when we want to make an inference, it means we want to move from the sample and make a generalization on the entire population. Okay, we want to leave from the sample and make a generalization on the entire population. Descriptive statistics only applies to the sample that we are using. You cannot, based on descriptive statistics, make a generalization on the entire population. Now, let's just say, okay, I decide to run a correlation analysis. Okay, let me just click here. I come, let's go to correlate by variant. Okay, let's say we still have this our two, these are our two values here, and I want to run a correlation analysis. Okay, and let's just say I go, okay, I don't, there will be another presentation on this, so we can actually see. Now, for the correlation analysis, we see that we are going to have a significant value. Now, this SIG, this sig value is very, very, very important. This is what we do. This is what we also refer to as a p-value. Okay. The significance value is what we refer to as a p-value. Now, in addition to doing the correlation, now this correlation here is the magnitude of the relationship between the two. So this is a negative correlation. Okay. This is a negative correlation between the variable household
Dr. Clement is having some internet problems, but he'll be back. He'll be back soon. Dr. Clement, could you just repeat the last
debt to income ratio.
last
It
couple
means
of minutes?
that the
Dr. Clement, you're having some internet issues and we can't hear you.
You have received another email right now saying, please consume webinar in
increasing. Okay.
progress. Zoom webinar. You need to join. Okay, you need to register. And
Dr. Clement will be back in a moment. He's just having some internet issues.
You will receive a confirmation email.
Hello, Dr. Clement.
Please do it as
You're muted. You're muted,
Can you hear
Clement.
me now?
I can hear you now, yes. Can we just repeat that the last 3 minutes because the internet blocked out?
Okay. Did you see how I did the correlation? Did you see how I arrived here?
We did, but the sound wasn't, the screen was
Okay.
fine, the sound wasn't working.
Okay. So let me take it all over again. Yeah,
Yeah.
so I'm actually trying to explain the difference between correlation and between descriptive and inferential statistics. Okay, so I just want to run a particular inferential statistical analysis and give you explain the difference. So let me run one of the easiest inferential statistic which you might have to do, which is the correlation analysis. Let's say I want to do measure the level of association, okay, or correlation between household income and debt to income ratio. I have the variables here. Okay, I think I showed you the first time how I got the variables here. So that's okay. So let me just run the analysis, and this is it. Okay, good. Now, inferential statistics and inferential analysis would inform us of the probability of what we have viewed in the sample occurring by chance. Okay? And keep in mind that if what we have viewed in the sample, there is a high probability that it occurred just by chance or by accident, let me put it that way, then we cannot be very sure that it's a good representation of what is happening in the entire population. Because to make an inference means you need to see the tendency in that particular variable and then make an inference saying, make a statement that englobes the entire population from which that sample was picked. Okay, so let's say in this sample of clients in this particular bank, we want to measure the correlation. It's just a sample, it's not all of the clients. Okay, and then make a generalization to all of the clients in that particular bank. Okay, so we want to see if there is any meaningful relationship or if there is any association between the household income and the debt to income ratio. Okay, now what we observe here is a minus 0.36. Okay, that's a negative 3%, 3.6% correlation. Okay, when the negative sign in the correlation indicates it's an indication of an inverse relationship. This means, in this case, it means the more the household income is growing, okay, the less the debt to income ratio. Okay, so it means there's a negative association between the two. But that association, which we have just described, is with respect to the sample that we have collected and which we are using for this particular analysis. Now, in order to make an inference, now for us to say, okay, there is a negative 3% association between the two, which is a very, very weak association. Okay, it's a very weak association. That there is a very, very weak, that there is a negative 3% association between these two. That's what we have observed in our sample. Now, how sure are we that this negative 3% that has been observed in this sample is an indication of what is happening in the entire population? How can we say, how sure can we make a declaration on the entire population saying, based on the negative 3% association that we have seen in this sample, how sure are we that that's what is happening in the entire population? And if we are very certain about the fact that it's a good representation of what is happening in the entire population, then we can make an inference. And for us to be able to measure the level, how sure we are, we will look at the significance value. This SIG here stands for statistical significance. also referred to as the p-value.
No,
Okay.
okay.
Now, in this particular, in SPSS, as well as in most of the times when you are conducting research, you are going to give a 5% error margin. Okay, a 5% error margin, 0.05 significant.
Where it does for your first and last name, that's it.
Okay, so when you
Where it
give your p-value, your error margin, you say, okay, I want to be able to live from what I've observed in my sample, based on what I've seen in my sample, make a generalization to the entire population, okay, on the entire population, but I'm going to give myself a 5% chance of error, okay? So how do you measure that then? This significance level or the p-value will tell you the probability that what you have observed in your sample occurred by chance.
And you put
okay?
your email.
So here we have a 0.300, which means there is a 30% chance that this negative 0.3% association which we have observed in that sample, there is a 30% chance there is a probability of 30% that that is occurring by chance. Okay. And since it is more than the error margin which we set of 5%, 30% is more than 5%,
Okay.
then we say, okay, no, we cannot really, based on this, make a good generalization on our entire population. And in this case, we see very clearly that we fail to reject the null hypothesis because there is a very, very big chance, more than 5% error chance that what we have seen in our sample occurred by chance. It is not, it's not, it's not,
email on your phone,
there is a
your
high
email
probability
account.
that it occurred by chance. It means there is a low probability that is a reflection of.
Just hang on a minute. Let me check in with
so inferential statistics, okay, inferential statistics permits you, it gives you a probability, a probability value, the p-value,
Give me 1 minute
which
to stay here and I will come back to you, okay?
which would indicate how sure you can be that what you have seen in your sample is a true reflection of what is happening in the entire population. But the whole idea of inferential statistics is to be able to make a generalization. It will give you a probability value based on which you can make a generalization. Okay, so let's say our p-value here was like 0.01, or there was just a 1% chance that what we have observed in our sample occurred by error, by chance. Then we'll say, okay, the probability that -3% will be observed occurring by chance is very low.
Send your presentation
There is actually negative 3.6% association between the household income and the debt to conclusion for the entire population.
And they will share the presentation and you just talk through your phone. Okay.
Yeah, I've tried to provide
open your email on your phone so we find
that answers the question. But let me just repeat again to keep it simple. Inferential statistics in inferential analysis, you obviously have a p-value, a significance value that gives you an indication whether or not to make a generalization on the entire population. Okay, thank you very much.
Excellent. Thank you, Dr. Clement. So the challenge is going back to IBM SPSS for payment. Does the School of Doctoral Studies have a discounted arrangement for students? And this is similar to another question where a student is asking if the full SPSS license is available as a resource for UNICAF students, or do they have to buy it themselves?
Okay, thank you very much. I think it is indicated in one of the courses or so, or somewhere maybe. Yeah, the students will have to buy SPSS themselves. Okay, and I'll strongly encourage you to buy it because you are not going to use it only for your studies. Okay, it can also be very helpful in maybe depending on what you do as a job. But whenever you have to deal with numbers to analyze data and to make an information and a decision based on numbers, SPSS can obviously be very meaningful. Okay, and also you would also need, I mean, you'll be using it even after you finish school. So I strongly recommend that you buy it. Yeah, you can buy SPSS. Unfortunately, the school does not buy SPSS for students. It's something you need to buy yourself. Okay. Thank you.
Excellent. How to perform simple linear regression in SPSS?
Okay. Simple linear regression analysis, you will have a presentation on that. Okay. You will have a presentation on simple linear regression in one of the other presentations. So don't worry very much about it. And after listening to the presentation, if you still have any questions, we will be very, very much available to answer the questions. But it's simple. You just click on analyze, you go to regression, okay? Then you click on linear, okay? The most cumbersome part in SPSS is entering the data. Once the data is already entered, it's easy. Then once you are there, you obviously need to choose your independent variable, okay? Let me just put like house. My independent variable, let me see, let me just take this one as, no, let me take out this one as my independent variable, debt to income ratio, and let me take household income. Okay, let me just run the thing very fast, just to show you, this is the model summary, and then this is your regression table, okay? So you can here see the significance of the regression. Okay, this is it instead. Yes, sum of squares mean, okay, you have your significance value here for your analysis. Okay, your regression analysis, you can get the significance value there. Okay, so well, that's how you run it, but you are going to have another presentation on these two variables were really not good variables for regression analysis, because there are also assumptions that need to be fulfilled. Like our data that we are using here is not normally distributed, okay? But in SPSS, you simply just have to come here to analyze regression, and then you click on linear regression analysis, and then you'll be able to run linear regression analysis. You can also, if you want to run binary regression analysis, you can also run it here, okay? So yeah, that is it. So yeah, there's also partial least square test, which is some form of regression analysis. But you're going to have another presentation on running regression analysis, which will show you the different assumptions and how to ensure that everything is okay. Okay, thank you.
Okay. Just a quick question now, because they didn't hear the answer last time when you said it. What p-value amount did you say is a significant indication for generalization?
Well, the first thing you need to be sure of is your error margin, okay? Your error margin, generally people use 5% error margin or 0.05. So they'll tell you their alpha is equal to 0.05, is 0.05, meaning they give themselves a 5% chance, a maximum of 5% chance of making of a 5% chance that that what observed in the sample is not occurring by chance. Okay, it's occurring by chance. Chance is a margin of 0.5%, meaning it's 5% probability.
Sorry, Clement, you're breaking up again. Could we try that again?
Can you hear me now?
Now I can hear you, yes.
Yes, I was saying the first thing which you need to determine is your margin of error. In most studies, it is 5%, okay, or 0.05. So you give yourself a 5% chance, okay, the maximum probability okay, that what you will observe in your sample is occurring by chance, you give yourself a maximum probability of 5%. Okay. Then when you run your analysis now, when your significance value is less than that 5%, okay, then you will say, okay, there is a less than 5% chance, okay, that what I have observed in my sample occurred by chance or by accident, okay? So if there is a low percentage probability that what is observed in the sample actually occurred by chance, it means there is a higher probability that it is a genuine reflection of what is happening in the entire population. So when that is the case, when your p-value is less than 0.05, which is the error margin which you set, okay, then you are going to say we reject the null hypothesis and we accept the alternative hypothesis, meaning, and we confirm the alternative hypothesis, meaning, okay, what we have observed in that sample, there is a very high chance, a more than 95% chance that what we have observed in that sample did not occur by chance, meaning it is a true reflection of what is happening in the entire population. So yeah, so the starting point is fixing the error margin, which generally is 5%. But some studies use 1%, okay, there is 0.001. Okay, some studies also use 10%, but that's very rare. You rarely see those two. Generally is 5% error margin. So that's how you do it. Mm-hmm.
Thank you, Dr. Clement. Now, this next question is a very large question, and we actually have seminars upcoming in this series, which will address some of them. We've got a student asking if you can explain the following methods: ANOVA, T and Z test methods, and chi-square methods. Now, we've got a 1.5 hour seminar on ANOVA and on the t-test. Now, to explain the z-test and the chi-square methods now, I think it's probably a bit much. But the question over to you, Dr. Clement.
Yeah, well, yeah, like you rightly said, we have seminars on ANOVA and on t-test. We would actually make time to do a presentation on the chi-square test. The chi-square test is very meaningful when you are measuring association using non-categorical data. Okay, so we will see. We'll definitely make time to do a presentation on that as well, and also on the Z test, I think. Okay.
Nice, thank you, Dr. Clement. Final question at the moment, if anybody has any other questions, please post them in the Q&A. But the final question for now: what are the common descriptive measurements, mean, median, etc., to be considered in educational research?
Well, once again, it depends on the kind of analysis. On what you want to bring out from the data. Okay. In your demographics, okay, generally when you are doing in your demographics, when you are doing your analysis for the demographic data, just like for the age, let's just take age. If you are doing your analysis age, let's just go descriptive statistics. Okay, the mean is the average age. Okay, you might want to communicate the average age of the participants. Okay, the median is the middle value if you put all the ages in an ascending order. Okay, and then you also have your standard deviation and the rest. So these can be useful for descriptive statistics. It depends on what you want to convey. Okay, as information. Let's just take this one, for example, the level of education. Okay, you might want to report the percentage level of education. Okay, this percentage of participants, 54% of participants did not finish high school, 27.6% of participants actually finished high school, 11% of participants actually went to college, 5.8% 8% of participants actually completed college, and just 6% of your participants actually had a postgraduate degree. So you might just, in certain cases, generally, when you are doing your when you are presenting the results, generally for the demographic section, we might want to see this. Okay, we might want to see this things like this, but it's just in my opinion, it's very trivial. Okay, it's just those initial analysis just to give us an idea of what their population actually of what their sample actually look like. But then the real analysis will be the inferential analysis, which you'll be doing after, and know for every inferential analysis that you'll be carrying out, you should be reporting the p-value, okay? And then you should be reporting some form of magnitude also, okay? Thank you.
Perfect. Thank you very much, Dr. Clement. We don't seem to have any more questions. So I think that's the end of the webinar. I think it went very well. Is there anything else you'd like to say? We might have one more question. Let's just see. Any idea of how expensive the SPS software is?
Well, I think the price changes over time. Just go to the website, and the price will obviously be communicated to you there. You can do a quick Google search, and it will tell you how much you would need to pay in order to acquire the license for the product.
Yes. Looking myself quickly at their pricing structures, they've got a variety of pricing structures starting at $100, which is probably more in the region of what a student would pay, and going all the way up to $25,250, which is probably a corporate version of some sort, and far too expensive for any of us to afford. As with all software, there's always options.
Sure.
It's just up to you to find those options. We can't officially recommend one pricing plan or source of software over another, but there's software is a very malleable market where you can usually find a good deal. So $99 or less is the answer, I would think.
Yeah. Well, and of course, you can always get a trial version and use for a few days.
Yeah.
Yeah, so I mean, if you're already done with all of your data collection, and you know exactly what you want to do, you get a trial version, run your analysis, and then yeah. But I mean, in the long run, it will definitely be useful if you can acquire the product and use.
And finally, there was a question about my name. I'm Sebastian Heller. I'm the Doctoral Studies Liaison. It's been a pleasure helping. Yeah.
Yeah. Thank you. Well, Sebastian, this question about getting SPSS keeps coming up. Okay, maybe we can discuss about it and maybe provide more information to students.
Yes, we might. Might possibly, if it's possible, to come with some sort of arrangement with the company. It's something that the finance department has to investigate. I'll bring it up there.
Yeah.
Okay.
That'd be good.
Nice. Thank you very much, Dr. Clement. Thank you to all our attendees. The recording will be available on the VLE within about a month. And we look forward to seeing you at the next seminars in the ongoing UU Stats series that we're putting out. Thank you very much and have a good afternoon. Bye-bye.
Thank you. Thank you. Bye-bye.